Hi, this video is for Tuesday, March 31st for calculus. I'm going to start teaching you about L'Hopital's rule. L'Hopital was a mathematician that I had you read an article about on Friday. It was just a little brief information about the guy that came up with this idea. So first, before you can use L'Hopital's rule, we need to discuss what indeterminate forms are. So this is coming directly from your notes. I'm going to read it to you. The forms 0 over 0 and infinity over infinity are called indeterminate because they do not guarantee that a limit exists, nor do they indicate what the limit is if one does exist. So if you ever get, when you're doing limits, infinity over infinity or 0 over 0, that really doesn't tell you anything. So that's why we have L'Hopital's rule. And before, we used other algebraic ideas, like using the highest power of x or factoring. Okay, well, this idea, you find the derivative of the top and the bottom of the fraction, and then you can use direct substitution to get the answer. Okay, so here we go. L'Hopital's rule looks something like this. So that means you find the derivative of the top function and the derivative of the bottom function. And to prove this theorem, we can use a more general result called the extended mean value theorem. So there's a box, theorem 8.3, that you can read for yourself, theorem 8.3. Okay, theorem 8.4 explains L'Hopital's rule a little bit better. So essentially, you're going to be told to find the limit of f of x over g of x as x approaches c, and you're going to have some kind of problem with that, so you'll have to find the derivative of the top part and the bottom part, and then you can substitute in what x is approaching. Alright, so we're going to try example 1. Alright, so example 1, we have this going on. Find the limit as x approaches 4, and we have 3 over x, or 3 times x minus 4, rather, over x squared minus 16. Okay, now you definitely could factor this and cancel some things out, which we learned a couple lessons ago. But this time we're going to use L'Hopital's rule. So first I'm going to distribute this 3, simplify this a bit. Okay, so that equals 3x minus 12 over x squared minus 16. And now we're going to find the derivative of the top part of the fraction. So the derivative of the top part is 3, because the derivative of 3x is 3. The derivative of 12 is 0. So we have 3. Now the derivative of the bottom part is going to be 2x, because if you remember finding derivatives, you're going to move this power to the front and take it down by 1. Okay? So we're going to have 2x. Alright, so now it says, find the limit as x approaches 4. So now we're going to plug in 4, where x is at right here. So it's going to equal 3 over 8. Because 2 times 4 is 8. Right, so that's it. We found the derivative of the top and the bottom, and then we plugged in what the limit is approaching. So hopefully that's not too bad. Okay, part B looks like this. Find the limit as x approaches negative 1 of x squared minus 2x minus 3 over x plus 1. Okay, so obviously if we plugged in negative 1 on the bottom, that would equal 0. So we're going to find the derivative of the top and the bottom. So the derivative of the top is 2x minus 2 and the derivative of the bottom is 1. Okay, so now we're going to plug in negative 1 for x. So 2 times negative 1 is negative 2 minus 2 over 1. So what does that equal? Negative 4. Okay, so that's it. Alright, now the next one is going to get a little crazy, but we can handle it. It's okay. Okay, so we're finding the limit as x approaches 6. We have the square root of x plus 10 over, minus 4 over x minus 6. Okay, now, this part here can be rewritten as x plus 10 to the 1/2 power. I don't know if you remember that from earlier this year, but you can rewrite that as x plus 10 to the 1/2 power. Okay? So that's another way of looking at it. Now, when we go to find the derivative of the top part of this, okay, we're going to have to move this power to the front, which is 1/2. Okay, and then you keep the inside stuff as it was. Take this power down by 1. So 1/2 minus 1 is negative 1/2. The derivative of 4 is 0, so we don't have to worry about that. Okay, and the derivative of the bottom part is 1. Okay, so I don't know about you, but that's a little ugly at the moment. So let's rewrite this. 1/2 negative exponents get moved to the bottom of the fraction, and then they become positive. So we have this times 1 over x plus 10 to the 1/2. So I kind of squished all that in there. Here's what it looks like. Okay, so it looks like that. And now we're going to plug in what our limit is approaching, which was 6. So if you plug a 6 in right here, 6 plus 10 is 16. And this means we're taking the square root of 16. So what is the square root of 16? Hopefully you're thinking to yourself, it's 4. Okay, so we're going to have 4 times 2, which is 8. So the answer is 1 over 8. Okay, like that. So like I said, that one was a little more complicated. You have to remember to move this power to the front, which is where this 1/2 came from. Keep the inside of this the same. Subtract 1 from that power, which is negative 1/2. And then you're pretty much golden. You got the rest. Okay? So, now that's if it was approaching a concrete number, our limit. Now our limit's going to be approaching infinity. But the idea is still the same. Okay, so example 2, part A says find the limit as x is approaching infinity of 2x plus 1 over 4x squared plus x. Okay, so we got to find the derivative of these things. So the derivative of the top part is going to be 2. Now, this is going to become 8x plus 1. Okay, so now we're finding the limit as x approaches infinity of 2 over 8x plus 1. Now, if you plug infinity in right here, this is going to become 2 over infinity. And do you remember what happens when infinity is on the bottom of the fraction? It's going to equal 0. So the limit here is 0. Okay, so that's it. Alright. We have one last problem, and then you'll have some to try for your homework for the day. And I want to keep telling you, I think you're all doing a great job so far. So keep up the good work. Let me know if you need any help. I'll be happy to help you. Of course, I'd be happier to help you in person, but we can't help that, so gotta do what we can. Alright, so this one says, find the limit as x approaches infinity. We've got 5x squared plus 3x minus 1 over 4x squared plus 5. Okay, now, before you get all in a hurry to do this new, find the derivative of the top and the bottom. If you recall from last lesson, when we divided by the highest power of x, and there was a trick to that, you can apply this trick here if you want to. I won't force you to do the whole derivative thing. So my prediction is that this is going to equal 5 over 4. And I'm saying that because this says 5x squared, this says 4x squared. And if we did the whole trick with the highest power of x and dividing by the highest power of x, this would equal 5 over 4. Okay, so I'm going to demonstrate the finding derivative part just to practice it for you. So the derivative of this would be 10x plus 3 over 8x. Okay, so if I'm going to plug in infinity, 10 times infinity plus 3, 8 times infinity, that's really not going to get me very far. So what happens is we're going to end up with 10 over 8. Because if we are plugging in infinity, this plus 3 part doesn't really matter a lot in the grand scheme of things. So it's going to be 10 over 8. And guess what that simplifies to? 5 over 4. Okay? So that's it. That's the lesson. So if you need any help, like I said, let me know. I miss you, and I hope that you're doing well and staying safe. So, bye.